Good day, sir. So today I will present to you my fourth recorded video recitation, which is about rotation and dynamics of rotation. So problem number 1. Wheel is rotating about an axis that is in the z direction. The angular velocity w sub c is negative 6.00 rad per second at the time of 0 second. Increases linearly with time and is positive 4.0 rad per second at the time of 7.00 seconds. We have taken counterclockwise rotation to be positive. So for letter A, is the angular acceleration during this time interval positive or negative? So for letter B, during what time interval is the speed of the wheel increasing or decreasing? For letter C, what is the angular displacement of the wheel at t is equals to 7.00 seconds? So for letter A, is the angular acceleration during this time interval positive or negative? So meron tayong given value na angular velocity, which is w sub c is equals to negative 6.00 rad per second at the time of 0 second. And meron din tayong a sub c is equals to 4.00 rad per second at the time of 7.00 seconds. So for letter A, ang hinahanap is the angular acceleration. So para makuha yung angular acceleration, ang ginamit ko pong formula is a sub c is equals to delta w sub c divided by delta time, which is equals din siya sa slope because they have the same formula and same value. So apply natin yung formula. So substitution ng mga given value. So we have 4.00 rad per second minus 6.00 rad per second all over 7.00 second minus 0 second, which results to the value of slope and to the value of angular acceleration, which is 10 rad over 7 seconds squared. So therefore it was positive. So this is our final answer for problem letter A. For letter B, during what time interval is the speed of the wheel increasing, decreasing? So I use the linear equation w sub c is equals to slope times t plus b, which equals to w sub c is equals to 10 over 7 times t minus 6.00. So para makuha yung time, nilet ko po na 0 yung w sub c. So 0 is equals to 10 over 7 times t minus 6.00. So ang time natin is equals to 4.2 second. So by graphing, at the point A between C, w sub c is negative and a sub c is positive. At the time interval of 0 less than or equal t less than 4.20, w sub c is decreasing. So at the point C between B, w sub c is positive and a sub c is also positive. So at the time interval of 4.20 less than t less than or equal 7.00, w sub c is increasing. So this is my final answer for letter B. So for letter C, what is the angular displacement of the wheel at t is equals to 7.00 seconds? So in this problem, ang ginamit ko pong formula is w sub c is equals to d theta over dt. So since angular displacement yung hinahanap, manipulate ko po yung formula into d theta is equals to w sub c times dt, where w sub c dt is equals to the linear equation of w sub c. So para makuha yung angular displacement, i-integrate natin tong equation na to, which equals to the integral of d theta is equals to the integral of w sub c dt, which is the quantity of 10 over 7 times t minus 6.00 dt. And then simplify natin. So the integral of d theta is equals to, so isa-substitute lang natin tong dt sa loob ng quantity. So magiging the integral of 10 over 7 times t dt minus the integral of 6.00 dt. And then simplify natin. So we have 10 over 7 times t squared over 2 minus the integral of 6.00 dt is equals to 6.00t. So our equation is theta is equals to 10 over t squared over 14 minus 6.00t. So since sabi dito, at time of 7.00 seconds, isa-substitute lang natin yung time into the equation. So we have theta is equals to 10 over 14 times 7.00 squared minus 6.00 times 7.00, which result to the value of angular displacement. Theta is equals to negative 7.00 rad. So this is my final answer for problem letter C. So let's proceed po for problem number 2. Three forces are applied to a wheel of radius 0.350 meter as shown in figure. One force is perpendicular to the rim, one is tangent to it, and the other one makes a 40.0 degrees angle with the radius. What is the net torque on the wheel due to these three forces for an axis perpendicular to the wheel and passing through its center? So in this problem, meron tayong value na force sub 1 is equals to 11.9 Newton, force sub 2 is equals to 14.6 Newton, force sub 3 is equals to 8.50 Newton, and the radius is equals to 0.350 meter, and the angle 1 is equals to 0 degrees, the angle 2 is equals to 40 degrees, the angle 3 is equals to 90 degrees. So para makuha yung net torque, ang una ko pong ginawa is, kinuha ko muna yung torque 1, torque 2, and torque 3. So, para makuha yun, ginamit ko pong formula is, torque is equals to force times inertia, which equals to the radius times force times sine theta. So, for torque sub 1, it is equals to 0.350 meter times 11.9 Newton times sine 0 degrees, which equals to the torque 1 is equals to 0. And for the torque 2 naman, I use the formula of negative radius force times sine theta, which equals to torque 2 is equals to negative 0.350 meter times 14.6 Newton sine 40 degrees, which results to the value of torque 2 is equals to negative 3.285 Newton times meter. So for torque 3 naman, I use the formula of positive radius times force times sine theta, which equals to torque 3 is equals to positive 0.350 meter times 8.50 Newton times sine 90 degrees, which results to torque T is equals to positive 2.975 Newton times meter. So, since meron na po akong value ng torque 1, torque 2, and torque 3, so pwede na po mag-proceed for calculating the net torque. So, by getting the net torque, I use the formula of net torque is equals to summation of torques, which equals to T sub 1 plus T sub 2 plus T sub 3, which equals to 0 plus negative 3.285 Newton times meter plus 2.975 Newton times meter, which results to the value of net torque, which is equal to negative 0.31 Newton times meter. So, it was in clockwise direction since it was in negative sign. So, therefore, this is my final answer for problem number 2. So, let's proceed for problem number 3. So, find the magnitude of the angular momentum of the second hand on a clock about an axis through the center of the clock face. The clock has a length of 15.0 cm and a mass of 6.00 gram. Take the second hand to be a slender rod rotating with constant angular velocity about one end. So, in this problem, meron po tayong given value ng length which is 15.0 cm and kinonvert ko po siya into meter. So, magiging 0.150 meter. And meron din po tayong value ng mass which is 6.00 gram and kinonvert ko po siya into kilogram which is equal siya sa 6.00 times 10 raised to negative 3 kg. So, for number 3, ang hinahanap is the magnitude of the angular momentum. So, para makuha yan, I use the formula of L is equals to inertia times angular velocity. So, para makuha yung magnitude, kailangan natin ng angular velocity and inertia. So, since meron na tayong value ng angular velocity, which is 1 revolution per minute, ang gagawin ko na lang is i-convert siya into rad per second. So, para ma-convert siya into rad per second, nag-multiply ako ng 2 pi rad over 1 revolution times 1 minute over 60 seconds, which results to 0.1047 rad per seconds. So, that's our angular velocity. So, since meron na tayong value ng angular velocity, ang kailangan na lang natin para makompute yung magnitude is kukunin natin yung inertia. So, by getting the inertia, I use the formula of I is equals to 1 over 3 times mass times length squared. And then, sinubstitute ko lang yung mga given value sa equation na to. So, we have 1 over 3 times 6.00 times 10 raised to negative 3 kg times 0.150 meter squared, which results to the value of inertia is equals to 4.50 times 10 raised to negative 5 kilograms times meter squared. And so, since meron na tayong inertia and meron na rin tayong angular velocity, I proceed for calculating the magnitude of the angular momentum by using the formula of L is equals to inertia times angular velocity, which equals to inertia is 4.50 times 10 raised to negative 5 kilograms times meter squared times the angular velocity, which is 0.1047 rad per second, which results to the value of magnitude, which is equals to 4.71 times 10 raised to negative 6 kilogram times meter squared over second. So, this is my final answer for problem number 3.